Hello folks, we're going to take a little break from exponentials and logarithms and have a look at quadratics for a couple of weeks. We're going to start with our old friend from GCSE, completing the square. So the work we're setting today is that I'm going to do some notes and examples on completing the square over the next 3 slides, and I'd like you to copy them down in full. We're then going to have a look at some exam and proof questions on the next 3 slides. I'll leave it up to you how much you want to write on those 3. Certainly, particularly with the proof one, it might just be a case of appreciating it. But make sure that you're happy with them. Lastly, I'd like you to try exercise 2C and 2D, which sounds like a lot, but they are very short exercises. There's like 4 questions in each one. And whatever you haven't finished of those 2 exercises, I would like you to finish for homework. Cheers. So what is completing the square? Well, essentially it's a way to rewrite quadratic expressions in such a way that we can say things about quadratics that we wouldn't otherwise be able to say, which is some bold claims, so let's back them up. So the formula is probably the place to start with here. This is what you should be familiar with from GCSE. X squared plus bx is x plus b over 2 squared minus b over 2 squared. Now, I think the important thing to remember there is that whatever this number is here, you halve it, and it goes there, and it goes there. That's really all you really need to be thinking about. I wouldn't want to actually learn this as a formula that I'm substituting into. I would think in this is b, halve it, I've got my b over 2. So let's look at some basic examples. If I've got x squared plus 8x, then I am saying here that my value of b is equal to 8, and so my b over 2 is going to be 4. So I could rewrite this as x plus 4 all squared, take away 4 squared. Now you tend not to leave it like that. You'd want to actually work out that 4 squared is 16, but that's it. That square has been completed. What about x squared minus 10x? How do signs come into this? Well, this is telling us that b equals minus 10. And so whenever we put b over 2 into our equation above, we're treating that as minus 5. So what would that look like? I'm going to do this in a profoundly stupid way to start with, just to point out the issues that you might have with signs. So if we're saying b over 2 is minus 5, we should have a minus 5 in there. And if we're saying b over 2 is minus 5, then we are taking away minus 5 squared. Now, you normally wouldn't write this. Plus and minus obviously just means x minus 5. And I think most people's instincts there are good. However, what is minus 5 all squared? Well, that's a minus times a minus. So it's 25, but we've still got this minus outside here. So you'll notice that when it's positive, we have a minus here, and when it's negative, we have a minus here. That's always the case. So you don't really need to think about the sign of b in lots of ways. All it's going to change is what's inside the bracket. The outside of the bracket won't really be affected, and people will make that mistake. I think they normally get the fact this will be minus 5 inside the bracket, but you'll see a lot of plus 25s taking place over here. Anyway, that's enough ranting about that. Are we done? Yeah. Okay, third question. What's our value of b here? Well, if we've just got x on its own, then b is equal to 1. So the b over 2 that we're going to use is going to be 0.5. We've also got this plus 9. Now, what we're going to do is very cleverly completely ignore that for a bit, and we're just going to complete the square with the rest. So x squared plus x, we're using b over 2 is 0.5, so that will go to x plus 0.5 squared. And then we'll have to take away 0.5 squared. And then we've also then at the very end got this plus 9 at the end. So can we tidy this up? Yes, we can. 0.5 squared is 0.25. And then we can add those two things together. So if we're fully simplifying, we should have x plus a half all squared plus 8.75. There we go. And obviously if you expand it and went back to it, you get to the start. However, you might not be someone that wants to work with decimals. You might be someone that wants to work with fractions. And sometimes it can be very helpful to write our numbers as fractions rather than decimals. Here, we're saying that b is equal to minus 7, so b over 2 is minus 7 over 2. Let's leave it as a fraction. Then we're going to get x minus 7 over 2 all squared, and then take away, we know this is always going to be take away. How do you square a fraction? You square the top, you square the bottom. So 7 squared is 49, 2 squared is 4, and then we've still got this minus 3 at the end. Now, particularly in a non-calculator situation, This makes it easier to deal with than having to do 3.5 times 3.5. It makes it easier to add these numbers together. But I will concede you do have a calculator on you at every step of the way. So up to you, whichever of those looks more aesthetically pleasing. Okay, let's carry on. So what you're essentially got to be aware of is that it's not always just going to be a case of take this number, half this number. Often you'll have a number in front which is not 1. We'll have something like 4x squared or 2x squared, but not just x squared. And the key here is that if we have kx squared, we have to take out a factor of k before we can use completing the squared, because completing the square needs x squared plus bx. It doesn't apply to ax squared plus bx, it applies to just x squared plus bx. And just to remind you, we're going for that. So let's apply this to 4 different questions. Our first one, we're going to take out a factor of 4, and we're going to take it out from the whole expression, so x squared plus 2x. We're then going to complete the square with just the x squared plus 2x, and we're going to leave that 4 sort of hanging around. So half of 2 is 1, so it's going to be x plus 1 all squared. Take away 1 squared, so that's 1. And then we can expand those brackets. We can say we've got 4 lots of x plus 1 all squared. It's kind of like you're just multiplying the 4 by that. And then we need 4 times 1 as well, so it'll be minus 4. And that's it. That's fully simplified. Okay. You might want to try it yourself on the next few. Unpause when you think you've had a go, but otherwise I'll continue talking through them. So we'll take out a factor of 2 here. We then complete the square with that, so that's going to be, I'm going to use fractions, 5 over 2 all squared and minus 25 over 4. Remember, you can square 5 over 2 by squaring the top and squaring the bottom. And then we can expand that out, and we can say we've got 2 lots of x minus 5 over 2 squared minus, that'll be 25 over 2, or 12.5. Okay. What about the next one? Well, firstly, I would reorder this. This is a recipe for disaster waiting to happen. We want the x squareds at the front, then the x, plus x, and then the minus 2. Okay, now think. Now we could take out a factor of minus 4, because we will have to take the sign out as well. This formula works for x squared, not for minus x squared. From everything. We could take out that minus 4 from everything, but I would recommend that you just take it out from the bits that involve x, and then you can take away 2 when everything is done. So we're going to do that. We're going to take out a factor of 4. We're going to say we've got x squared, and then this is going to go to minus a quarter x, I guess. Should be a squared there. And then we've still got this minus 2 at the end that we're going to think about when we're done. So let's complete the square. We've got minus 4, lots of. So what's half of a quarter? That is an eighth. And then we need to take away an eighth squared, so 1 squared over 8 squared. Minus 2. Then we can expand our bracket. So it's going to give minus times minus is positives, and that will give us 1/16 minus 2. And then we can put all of this together. 1/16 minus 2 would be minus 31/16. Yeah, there we go. That's about as horrible as I think they can get, even at A level, to be fair. Taking out a negative fraction, ugh. Not pleasant. Okay, now for the very last one, hopefully you have tried this one. We're going to take out a factor of 2, but again we're only going to take it from the x squared and x part. So I've got again my favourite 7 over 2x, and then I've got a plus 10 happening at the end. So we've got 2 lots of x minus 7 over 4. So if you want to halve a fraction, you can just double the denominator, top tip. Square that, 49 over 16, 7 squared over 4 squared, and then plus 10. So we'll get overall 2 lots of x minus 7 over 4 squared minus 49 over 8 plus 10. And so overall we'll get another 31 plus 31 over 8. Okay, cool. So that's as difficult as it's going to get in terms of just completing the square, but we're now going to look at a couple of uses of completing the square. So one thing we can use completing the square to do is to solve equations, and I want to point out it is okay if we want to divide by a constant. More on that in a little bit. So let's look at this first one. What we want to do is we want to get just the parts of the completing the square on one side. So we're going to subtract our 2. Then we're going to complete the square. So we're going to go to 5 over 2 squared minus 25 over 4. 5 squared over 2 squared is equal to minus 2. Then we're going to add across our 25 over 4, which will get us up to 17 over 4. And then we will square root. Remember, if you square root, you should have a plus and a minus possible answer. Sometimes that's forgotten. And then we'll finally subtract our 5 over 2 across. Now theoretically, this square root could become root 17 over 2, because you can square root the bottom. But yeah, that's about as simple as it needs to get. And we have solved our quadratic in a different way than factorizing or quadratic formula. Okay, so this second one brings in this point, it is okay to divide by a constant first, because we could just divide everything by 3 before we start. If we do that, we'll get ourselves to x squared plus 5x minus 5/3 is equal to 0, and then we have a very comparable question to what we've just worked out. If you just take out a factor of 3, just because that's what you do when you're simplifying with completing the square, it'll still work, it'll just take like twice the amount of lines. So let's finish this off. So we'll halve 5 to get 5 over 2. We'll take away 25 over 4 again. We've got minus 5/3 is 0. We'll add those fractions together and get that they overall are 95 over 12, which is just a lovely fraction. We will subtract that. And finally, we will square root and subtract our 5 over 2. You could probably do this in one step if you want, but I'm trying to do things properly here. Something else that people will do wrong is they'll have their square root gradually just sort of shrink up until it's just on the numerator. Make sure if it's square rooting the whole thing that you do square root the whole fraction. Okay, another example of it being okay to divide by a constant first here. We're going to divide everything by 10, because completing the square works well when it's just x squared. So x squared minus 1.8x is equal to 0.2. Let's try some decimals for a bit. So we would halve that, 0.9, square it, take it away, 0.81. That's equal to 0.2. Then we could add our 0.81 to the other side. We could square root. And we could, should have got rid of the square there. And then we could finally add our 0.9 across. And there you go. Now something that is not examinable, but is cool, is this proof of the quadratic formula. And it uses completing the square. Now, I thoroughly recommend you watch this proof. It's really nice, it's excellent, but it is not going to be tested on the exam. So, up to you how much notes you want to make on it. Anyway, we'll start with ax squared plus bx plus c equals 0. This is the classic quadratic. And if you think about what we're trying to get, we're trying to show that x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And we're going to show how that sort of thing comes about. So, we'll start by subtracting the c to the other side. We're then going to divide by a, just like we did before, and that's going to divide everything by a. And then we can complete the square with the left-hand side here. Now remember what I said with a fraction, if you're halving it, that just kind of doubles the denominator. So this would complete the square to b over 2a in a bracket squared, and then take away b over 2a all squared. What do we do from here? Well, we could work out what this square is. So if you square that fraction, you'll get yourself b squared over 4a squared. And then we could subtract it to the other side. So let's do that. So we've got x plus b over 2a all squared equals b squared over 4a squared, because that's positive when we move it across, minus c over a. And And then we could get a common denominator going for this, couldn't we? So if we want to give these a common denominator, we could give them the common denominator 4a squared. The first one already has that common denominator, so that's still going to be b squared. And then the other one needs to be times by 4a to make it happen, so we're going to have 4ac. So overall, this is b squared minus 4ac all over 4a squared. Cool. So we've got x plus b over 2a, and let's take the square root across as well, is plus or minus the square root of this fraction thing we found out, b squared minus 4ac all over 4a squared. What's the last thing we can do here? Well, we can simplify that square root. We can square root the top and bottom separately, and we can say that we've got b squared minus 4ac on the top. The bottom can be square rooted, so 4 square roots to 2, a square roots to a, or a squared square roots to a. And now we're nearly there, we just need to now subtract the minus b over 2a to the side. We'll have minus b plus or minus the square root of b squared minus 4 ac all over 2a. Yeah, that is cool, you're right. Okay, last two slides. So here's a couple of exam questions, just in terms of different ways this sort of thing can be asked. This first one is a completing the square question. It tells us that we have something that when we complete the square looks like this, and we want to find out the values of a and b. There's lots of ways of obviously doing this. I would suggest you could expand the right hand side and compare it, or we might complete the square with the left hand side and do something with that. Let's do the first option there. The second option, let's complete the square. So we've got x squared plus ax, that's going to go to x squared plus a over 2, rather it's going to go to x plus a over 2 all squared, take away a over 2 squared, so a squared over 4 plus b, and we're saying that this is equal to x minus 7 all squared minus a, so we can tell straight away from that that a over 2 and 7, or minus 7, are going to be the same thing. So we can go a over 2 is equal to minus 7, so a is equal to minus 14. So what does that actually give us? That gives us that we've got x minus 7 all squared, take away a squared over 4, so that's going to be minus 49, because it's just 7 squared, plus b. And that's equal to our x minus 7 all squared, and it says it's minus a here, so that's going to be plus 14. So what we need now is for the minus 49 plus b to be the same as plus 14. So we can say minus 49 plus b equals 14. We could add the 49 across and get that b is 63. So there we go, just a bit of comparing coefficients. What about the second question? Well, this again is a completing the square question. It's saying show it can be written in this particular form. So we can do that dead straightforward. Halve it, take it away, so 4 squared is 16. And then we've got a plus 20 on the end that we need to think about as well. So yeah, it can be written in that form because we've got minus a and plus a. We've got 4 and minus 4. A is an integer, yep. So we've matched all the criteria. And then there's this hence. Hence explain how you know that this is always positive. And this is leading into what we're going to look at on Friday when we start sketching graphs and things. Why do we know this is always positive? Well, this is a square number. This is 4. Square numbers are always greater than or equal to 0. 4 is obviously greater than or equal to 0. So what we're saying is this is a positive number plus a positive number. And any positive number plus a positive number is obviously going to be greater than or equal to 0, is going to be positive. So essentially the key thing is that squares are positive, and that's what you have to take forward. Okay, last question to consider. So same sort of thing, everything kind of put together. I'd like you to try this first, unpause the video when you're ready. I'm going to start my answer in 3, 2, 1. Okay, so we do have to take out a factor here. We can't just divide it because it's not an equation. So we'll take out our factor and then we'll have our plus k sort of hanging loose in the background. We'll then complete the square with this. So this is going to go to 5 over 4 for I think the third time we've seen that. Take away 25 over 16. And then we still got this plus k. We can expand our brackets. That's 25 over 8. And then plus k. And is that as simple as we can do it? Yeah, that basically is. So as far as this is concerned, our a is equal to 2. Our b is equal to 5 over 4. And our c is equal to this nonsense here. K minus 25 over 8, maybe. So it says we want to find all the values of k where this line does not intersect the line y equals 3. So what this is some sort of quadratic. The line y equals 3, let's draw it in a different colour, looks something like that. And a quadratic curve looks something like that. And what we want is for it not to intersect that line. So it's going to have to be entirely above it. So what is the minimum value of this thing that we've created? Well, this is a square number. And square numbers are, as we said, positive. However, they could be equal to 0. So the lowest value this could have, if we're talking about minimums, let's say the square is equal to 0. The extra bit, therefore, is what's left over. And that's constant. We can't do anything about it. So the minimum value that this could have would be 0 minus 25 over 8 plus k. It would be, let's rearrange it slightly, k minus 25 over 8 is the lowest this can go. Now, if we don't want it to touch 3, that means this can't be equal to 3. It's got to be bigger than 3. And we could sort of solve this as an inequality. Let's take it over here. So we're saying k minus 25 over 8 is greater than 3. We could add the 25 over 8 across and just say that k is therefore bigger than 49 over 8. Those are the values of k where it does not intersect that line. Okie dokie. Right, so you've got some work to do. Best of luck. I'll see you Friday.